What happens when a nation has to rebuild its entire armored doctrine while actively losing a war? You get machines designed for weeks, not years. The truth is buried in factory production quotas and cold logistics. The system didn't demand perfection, it demanded massive volume and tactical availability. A tank was just a line in a supply spreadsheet. I spent countless hours digging through original combat archives to rank every mass-produced Soviet tank of the war. We are skipping Lend-Lease imports and armored cars to focus on native steel. And hey, I am only human, so if I miss a minor factory variant, correct me in the comments. Let's look at the real math of war. Chapter 1. The Expendable Scouts. We start at the bottom of the logistical chain. The machines forced to buy time with their physical presence. The T-26 was an institutional relic by 1941. The planners knew it. Its 15 millimeters of riveted steel wasn't armor. It was just a weather shield against operational friction. In the early clashes, these machines suffered catastrophic logistical exhaustion, essentially serving as a physical burden on retreating columns. The speed was abysmal, and the mechanical reliability was a constant headache for the crews. But there is a flip side to this administrative reality. The 45 millimeter main gun was surprisingly capable against early German armor. If a crew could secure a stationary ambush position, this systemic adaptation allowed it to punch through light panzers with cold efficiency. It failed as a modern tank, but as a mobile anti-tank platform, it offered a decent tactical return on investment. Next up, the BT-7. On paper, it was a tactical dream. The famous Christie suspension allowed it to drop its tracks and drive on wheels at highway speeds. Soviet planners envisioned these things exploiting breakthroughs and rushing deep into enemy territory. It was pure offensive optimism built into a steel chassis, but administrative fantasy met the harsh administrative reality of 1941. Those highways didn't exist where it mattered. In the mud, the wheel drive was completely useless. The armor was paper-thin, meaning any systemic disruption, like a hidden anti-tank gun, turned the fast Scout into an immediate logistical write-off. They were fast, sure, but they outran their own supply lines. By late 1941, the system was bleeding. When I look at the production sheets, the T-60 wasn't a tank, it was a desperate institutional reflex. Built in tractor factories using commercial truck engines, its 20mm gun was functionally useless against heavy German armor. It was an uncomfortable metal box where crews faced maximum operational exposure just to fill gaps in the line. Yet, this little machine saved the tactical continuity. When heavy industry was relocating east, the T-60 kept the infantry supported. Because it was so light, it could cross frozen swamps that swallowed heavier panzers. It was terrible at fighting, but it excelled at existing exactly when the math of war demanded a physical presence. The T-70 was the final attempt to make light tanks relevant. I read the original crew reports, and the ergonomic reality was brutal. It had a two-man crew. The commander was simultaneously the gunner and the loader. In the chaos of combat, this human bottleneck caused a massive drop in operational efficiency. Against upgraded German medium armor, it was a mathematical dead end. But the factory logistics tell a different story. They strapped two standard truck engines together to power it. This systemic adaptation meant spare parts were everywhere. The sloped armor could actually deflect light anti-tank fire. As long as it avoided frontline clashes and stuck to reconnaissance, it provided a cheap, steady physical presence for the army. Looking at the data, the progression is clear. The T-26 and BT-7 represented pre-war optimism, while the T-70 was a cheap adaptation to industrial limits. Light tanks simply lacked the physical scale to survive modern operational friction. Chapter 2. The factory workhorses. The system needed a new universal platform. This brings me to the core of the Soviet machine, the medium tanks. These were not precision instruments, they were the backbone of the supply chain. The early T-34/76 is remembered as an engineering masterpiece. On paper, it was. The combination of highly sloped armor, a reliable diesel engine, and a 76mm gun created a mathematical shockwave for German planners in 1941. It was functionally immune to standard anti-tank weapons of the time. My research shows its design was the absolute peak of armored theory. But the administrative execution was a disaster. I found reports showing that factory tolerances were so rough, Early transmissions routinely shattered after just 50 kilometers. Planners didn't even install radios in most of these machines. The commander had to communicate with signal flags, operating almost completely blind. The tank was a theoretical marvel, but the institutional reality turned it into a logistical gamble that often broke down before seeing combat. By 1942, the T-34/76, late model, emerged from pure industrial desperation. The factories stripped away every non-essential feature to meet quota. The finish was so rough you could literally cut your hand on the armor plates. Crew comfort was a non-factor, and the two-man turret still forced the commander to act as the gunner. Aiming and firing while trying to manage a battlefield created a severe operational bottleneck under fire. It was a crude metal box built for a short, brutal lifespan. Yet, this brutal simplification saved the entire system. The hexagonal turret gave slightly more working space, and the sheer volume of production simply overwhelmed German supply lines. The system didn't need a perfect tank. It needed a tank that took exactly 8,000 man-hours to build. They swapped rubber road wheels for all steel ones to save strategic resources. It vibrated violently, but it flooded the front with continuous physical presence. By 1944, the institutional math shifted again. The T-34/85 arrived as the definitive medium tank. They finally gave the crew a three-man turret, breaking the terrible ergonomic bottleneck. The commander could actually command. The new 85mm gun restored the tactical equilibrium against heavy German cats like the Tiger. It was the ultimate factory evolution, balancing armor, firepower, and mass production. But let's look at the survival statistics. The hull armor remained exactly the same as in 1941. Against late-war anti-tank weapons, those 45mm of sloped steel offered zero operational security. Crews were basically sitting in a highly explosive box surrounded by external fuel tanks. The system accepted massive human costs because the factory lines could pump these out faster than they could be destroyed. It was a cold numbers game, and the crews paid the physical toll. Reviewing the medium class, I see a system optimizing for sheer volume. The early 76 was a flawed theoretical marvel. The late 76 was a desperate factory simplification, and the 85 traded hull survivability for aggressive firepower. Chapter 3. The Breakthrough Heavies. But volume alone couldn't crack fortified lines. The system needed blunt force trauma. We are moving into the heavy machines, designed to absorb incoming fire and break tactical stalemates. In 1941, the KV-1 was an absolute operational shock. I've read German field reports where 37mm anti-tank rounds literally bounced off its 75mm frontal plates. It was a rolling bunker, capable of holding up entire enemy divisions purely through its physical mass and invulnerability. It functioned as a tactical roadblock that gave the system precious time to breathe. But the logistical reality was a nightmare. The transmission was tragically unsuited for a 45-ton machine. I found manuals instructing drivers to literally use a sledgehammer to force the gear shift. Most early KV-1s were not destroyed by enemy fire. They were abandoned by their crews after the gearbox inevitably shredded itself. The system built a fortress, but forgot to give it reliable legs. Then there is the KV-2. From an engineering standpoint, it was a joke. They slapped a massive 152mm howitzer into a boxy turret that made it as tall as a house. The center of gravity was completely ruined. If the tank was on a slight incline, the turret motor lacked the power to actually rotate. It was a prime target, slow, clumsy, and mechanically doomed from the start. However, the sheer kinetic energy of that gun was undeniable. When a KV-2 managed to set up in a static defensive position, it was terrifying. A single 152mm high-explosive shell could tear the turret off a Panzer IV through blunt force trauma alone. The institutional math was simple. It was an awful tank, but an incredibly cheap way to bring siege artillery to the front line without waiting for tractors. IS-1, heavy tank. By 1943, the appearance of the German Tiger tank caused institutional panic. The IS-1 was the immediate, rushed response. I look at the blueprints, and it screams of compromise. They took a new heavy chassis and mounted the same 85mm gun used on medium tanks. For a heavy breakthrough machine, that firepower was already statistically insufficient. It was an awkward, operational stopgap that the system abandoned almost immediately. But as an administrative stepping stone, it was crucial. The new chassis finally solved the catastrophic transmission failures of the KV series. It introduced heavy sloped casting that made the hull vastly more survivable. It was a statistical failure in combat, but it provided the reliable mechanical legs the system desperately needed for the final push. That final push was delivered by the IS-2. This is the legend, the ultimate blunt instrument. They dropped a massive 122mm artillery piece right into the turret. The kinetic energy was so immense, it could literally crack the hull plates of a Panther tank without even penetrating. The sloped frontal armor finally provided true operational security. It was the heavy sledgehammer the Soviet machine needed to break fortified cities. But the physical burden on the crew was immense. The 122mm ammunition was split into two separate heavy pieces, crushing the rate of fire to barely 2 rounds a minute. Even worse, the tank only carried 28 rounds total. The system fully accepted that an IS-2 would run dry in a sustained firefight. Planners treated it as a disposable wedge. Crack the line, empty the rack, and fall back, leaving the crew highly vulnerable in prolonged engagements. The heavy tank progression reveals a harsh truth. The early designs were mechanical liabilities. By the end, the system solved the armor, but sacrificed sustained combat capability for raw, single-strike kinetic impact. Chapter 4. The Mobile Bunkers. Turrets require precision ball bearings, extra space, and complex machining. When you are losing factories, you can't afford that. You build casemates. Welcome to the self-propelled guns. I look at the Su-76, and I see absolute institutional ruthlessness. Crews nicknamed it the Bare Arse for a reason. Built on the outdated T-70 chassis, it had an open top. This meant zero operational security against artillery shrapnel, grenades, or even heavy rain. The system placed these men in a motorized steel bucket, accepting massive physical casualties, simply because adding a steel roof would slow down the assembly line. But here is the cynical genius of it. Because it was so cheap, it was everywhere. It gave the infantry direct 76mm fire support exactly when they needed it. The open top meant the crew could hear infantry commanders shouting targets. It was a terrible place to be, but it was a masterclass in logistical efficiency. Moving up the chain, we find the Su-85. Archival reports show this machine was practically blind. Early versions lacked a commander's cupola. If a German unit flanked it, the operational rigidity of having no turret meant the entire vehicle had to physically turn to face the threat. By the time the driver shifted the gears, it was usually too late. Yet it served a vital administrative purpose. It brought the deadly 85mm gun to the front line, months before the T-34/85 turret was ready. It was an urgent mathematical patch. The system needed something to punch through heavy German armor right now, and welding a gun directly to a hull was the fastest tactical solution available. Then came the Su-100. This is where Soviet casemates became truly lethal. My numbers show the 100mm naval gun had absolutely devastating ballistics. It was a dedicated tank killer, capable of slicing through heavily armored targets at extreme ranges. This was the system finally producing a specialized, high-quality mathematical solution, rather than just a massive quantity of steel. But physics exacts a toll. That massive gun barrel was so heavy, it completely overloaded the front suspension of the T-34 chassis. Driving through ditches, the barrel would literally slam into the dirt. Furthermore, the massive shells cramped the interior, forcing a terrible rate of fire. It was a brilliant sniper, but functionally exhausting for the men trapped inside. Finally, the ISU-152, known as the Beast Killer. When precision engineering failed, the institutional math opted for blunt force trauma. A high-explosive 152mm shell didn't need to penetrate a German Tiger. The kinetic energy transfer simply crushed the armor inwards and ripped the turret off. It provided maximum physical deterrence on the battlefield, but the administrative cost was crippling. It carried a severely restricted payload of around 20 rounds. The two-piece ammunition weighed so much that loading took over a minute in stressful combat conditions. It was a one-shot sledgehammer. Once you fired, the crew sat in a metal box, highly vulnerable, waiting for the mechanical breach to finally clear. The SPG class proves that when factories fail to produce turrets, the system simply adapts. It traded crew comfort and tactical flexibility for raw, immediate firepower. So when I close these archival files and look at the brutal math of Soviet production from 1939 to 1945, three systemic truths about their armored machine become perfectly clear. Number one, the administrative machine actively weaponized imperfection. The system understood that a flawless, over-engineered tank is completely useless if your factories can only build 10 of them a month. They accepted terrible ergonomics, missing radios, and rough armor cuts because pure, overwhelming physical volume was the only metric that could break the German supply lines. Number two, tactical flexibility is a luxury you lose when you are fighting for survival. The self-propelled gun class proved that removing a turret is the ultimate bureaucratic shortcut to getting massive kinetic energy onto the battlefield. The factories traded crew comfort and operational vision for raw, immediate firepower, proving that institutional desperation breeds highly effective, if deeply flawed, solutions. And number three, the harshest rule of this administrative reality. The system achieved its final victory by constantly converting extreme human endurance into logistical time. Planners built machines with thin armor or zero operational security, fully knowing the casualty rates, because on a spreadsheet the tanks were replaceable assets, and the men inside were simply part of the operational cost of doing business. Thanks for watching. A huge thank you to everyone leaving detailed corrections in the comments. Some of you pointed out my recent videos were a bit too negative, and I hear you. I'm just one guy doing this research, but I'm actively working to balance the scales now, showing both the brutal flaws and the real engineering triumphs. Your knowledge genuinely helps me make the scripts more accurate, so keep it coming. Before you go, let me know. If you had to ride out the war in one of these Soviet machines, which one are you picking? The thick armor of the IS-2 or a mass-produced T-34? Let's talk in the comments. See you in the next one.